Hi, and welcome back to I Know Fact All About That, a timely episode 3, where we know fact all about time. If it's your first time here, we'll explain the facts. If you've been here before, you know what we're doing. There's 4 guests, there's 5 facts each, and one of those facts is a lie. At the end, we'll try to ferret out that lie. If you hear this sound,
fact off.
That means 2 people have the same fact, or 2 or more people have the same fact, and they will enter a quickfire quiz round to see who's going to wear the I'm with Stupid t-shirt. So joining me this week are I've had the time of my life, Bree.
Hello.
Time after time, Nick.
Hey.
And our first special guest star, if I could turn back time, Corey. Okay, so let's get into it straight away with Fact 1. I'll go first. The block universe theory is supported by the theory of relativity because the theory of relativity states that there's no absolute time and that time is relative to the observer. Now, I have a prop to explain block time, or the block universe theory. So the block universe theory is this is the whole time and space. And let's say we are in the middle. That's the past, that's the future, but none of them exist independently of each other. The past, the future, and the present all exist at the same time. Therefore, we could enter any point in time within this block universe, making past, present, and future moot. That means that the future has already been determined, so we have no free will. Everything's predetermined. So it means we're not an observer of the universe. It just means we're part of it, which I think is kind of beautiful and kind of scary at the same time.
You came in hard. You were like, I was going to ease into this, but you just started melting minds right from the word go.
That's why I brought my feeler block.
Gosh, okay.
Okay, Bree, let's go with fact 1 for you.
Okay, the days are getting longer. No one fact off with me because I don't know much about time. Okay, so the days are getting longer. So from our space episode, we know that there's a moon orbiting the Earth, and we know that it's moving away. So the moon's orbit of the Earth is causing, and the fact that it's moving further away is causing an angular momentum, a wobble, so to speak, in our spin. So this wobble in Earth's own spin is slowing it down. And we can calculate, well, we can't calculate because we're idiots, but scientists can calculate that this wobble is slowing us down by approximately a whopping 2 milliseconds per century. Doesn't seem like much, but if you take that back to the time of the dinosaurs 620 million years ago, that made the days only 21 hours long, which I think is quite fascinating. The moon was also much closer to Earth back then. So that's my fact. Imagine traveling back in time. You'd feel like you're on an acid trip, like this massive moon and, whoa, time's going so fast.
Not to mention all the dinosaurs.
And then the dinosaurs,
Yeah, T-Rex, I'll meet you here tomorrow at 12 o'clock. Oh, no, that doesn't work.
Yeah.
Okay, Mr. Royal.
So the inventor of atomic time is a guy called Louis Essen, a British physicist. And he was fundamental in essentially coming up with this concept of measuring atomic time. So Essen came up with this method of measuring atomic time by analysing the vibration of cesium atoms.
Oh, I think mine's close enough that this is going to go down, but continue.
So, Essen's findings led to the development of the first atomic clock. In a nutshell.
And the atomic clocks are just meant to be precise.
Yeah,
the most
precise
measurement of time that we have on the planet.
To within a millionth of a second in terms of the accuracy. So incredibly accurate, an incredibly accurate way of telling time.
Yeah, don't count me on this, or don't fact check me on this, but I'm pretty sure they go off by 1 second every 10,000 years or something like that. That's how accurate they are, as opposed to other clocks that are a little bit less accurate.
People in the comments, fact check Corey on that.
Yeah. It's in the thousands of years. Let's just say that.
Okay, interesting. So when was it discovered?
We're talking 1940s, 1950s, and by mid-1950s, the atomic clock had been developed.
Okay, fact one for Corey.
All right. So I was going to ease into it. I didn't want to go into paradoxes where I end up being my own grandfather or something like that. So just a fun one about the way we perceive time, I guess, when we read history books and stuff like that. So Cleopatra lived closer to the building of the first Pizza Hut than she did to the building of the pyramids. So we're talking like the pyramids were 2490 BC. And Cleopatra she died in about 30 BC. And the first Pizza Hut was built in 1958. So we're talking about 500 years. She was closer by 500 years to the building of the first Pizza Hut than the pyramids.
Enter equation graphic.
Yeah.
on every episode.
I think there's going to be a few things popping up on the screen.
Okay, so Cleopatra is closer to the building of the first Pizza Hut than she was to the building of the first pyramids.
Oh, pyramids of Giza. Yeah.
The pyramids of Giza.
So, that's just, you just assume, right? Cleopatra.
Which are in London, aren't they?
Yeah. Fact check in the comments.
Yes, the London Museum.
The Pyramid of Giza.
But like you read the history books and you assume all of this stuff like Rome and Egypt and all these kinds of stuff happened in a really confined space in time. Or time period, but in fact, we're a lot closer to some of these events than we realize, or some of these people than we realize.
Okay, well, that is the end of the first round of facts. All interesting. I think I should start off with fact 2 because I'm going to counteract one of your facts. Because the amount of days in a year is slowly increasing as days get shorter. So in the time of the dinosaurs, there was around, the span of the dinosaurs is a long time, but on an average, the days in a year were 358 to 365 days now. Same, the Earth's spin is getting faster because the moon is moving further away from us. Therefore, its gravitational pull isn't having so much of an effect on Earth. So we are speeding up by 1.7 milliseconds every century. So in 1 million years' time, days will be 23 hours long. And in 1 billion years' time, days will only be 18 hours long, meaning that a year will consist of 487 days. So more time to save for Christmas.
Does annual leave increase as well, do you think, with that? Or is it still just the standard 4 weeks in a year?
I think it should extend to 12
I
weeks
think
in a
the
year.
unions are going to have something to say about this.
I reckon we'll be on the 4-day working week by then.
I'm pretty sure we'll be all uploaded into computers by then. So
So we find ourselves in an interesting paradox there because either Brie or myself is telling the truth or telling a lie. Interesting.
And I think we get to be the jury in that fact, don't we? And as they go head to head.
Oh, you'll find out at the end.
Okay, so let's go on to fact 2 for Brie.
Okay, well, this sort of flows on from Corey's fact about the Egyptians and just how widespread their knowledge and history goes. So the Egyptians and the Babylonians did it first. Archaeological evidence shows that the Egyptians and the Babylonians started recording time in a sense that we know it at least 5,000 years ago. They created calendars to coordinate communal events, schedule shipping, and also to regulate planting and harvesting cycles. So the earliest calendars that we found, not me, someone else, scientists found, so the calendars were based on 3 natural cycles. It looked at the solar day, the length of the day with the darkness before and after, the lunar month, and it followed the different phases of the moon, and then it was the solar year, which looked at the different seasons of the year with rainstorms, floods, all that sort of stuff. So, yeah, that's at least 5,000 years ago were the earliest.
I find that really interesting. I find how ancient civilizations would have perceived of stuff like time and stuff like that to how we kind of perceive it today.
Well, time to us is a feeler yoga block.
I mean, it's quite interesting because this is the subject of time, I've never seen science and philosophy intertwine so much, where science and philosophy are both feeding off each other to try to explain time. And some of the fundamentals of time were figured out by the ancient Greeks. It starts off obviously as a way to kind of measure day and night, and then as we progress, as society and civilization starts to grow, it becomes more and more important to us. Interesting.
And we just, I guess, come up with different ways to measure more and more accurately, right? So initially it's the sun and the moon moving around, and then mathematics is invented, and then we can kind of be more precise about how we measure and assess those things.
Until we get to the atomic clock. Okay, let's go fact 2, Nick.
So have you ever considered how the numbering in the time system that we use today, it's all equally divided by 6 or 60. So we've got, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, so on and so forth. So the system that we operate our time within is the base 60 system or the sexagesimal system. So the Sumerians, so it's a civilization that is located where modern day Iraq is. So they came up with the the base 60 system. So it was later adopted by the Babylonians and the Egyptians. And the Babylonians made a significant sort of adaptation of the base 60 system where they sort of looked at it over a 24-hour time period. So in terms of mathematics, it's quite fascinating how our time is all able to be, the way we break down time is able to be equally divided and calculated in a way where there's no fractions, unless we get into the milliseconds and beyond seconds. But essentially, this sort of way of describing time came about 2000 BC.
You're all shattering my hopes and dreams. You're picking me apart. Just let me have a fact.
Just everyone just gets challenged instantly.
Well, no, it's interesting. So it's around this time period, I guess, where time and our view on as society, we were sort of forward planning and thinking on these longer time scales and creating calendars and tying in these key events throughout the year in a manner that everyone could relate to at that time in society.
Well, I think you've got a very disorganized. You can't have a structured society or an effective society without some sort of time management. And it's the crops. You couldn't pop down to Woolies. You had to grow what you ate, and you can't grow everything in every season. So it was sort of out of necessity, wasn't it, for all of these civilizations?
Indeed. And maybe it's worth looking into that link between the movement from hunter-gatherer societies to farming societies, where we started to build these civilizations and required some sort of structure or order in the way.
Yeah, but even prior to that, when we had nomadic communities, they moved with the seasons to follow the food and to follow all the flora and fauna as it rotated around the different continents based on seasons.
That's the switch, isn't it? From the biological clocks of life to the mechanical, mathematical.
Yeah, I think going from the biology to introducing the maths.
And those Sumerians, clever people,
And they were good.
I think you'll find too that there's probably a peak in those really successful societies where they've come out of just subsistence, work, like basically day to day just surviving, to having time and space in their head to think about things a little bit more. So each of these peaks, whether it's the Sumerians and then the Romans and the Egyptians, they're at the kind of peak civilizations, right, where people actually live at the top tiers of society and have the time to think about things.
Well, I got a little bit sad researching some of this stuff because I was listening to all of the great thinkers, the stuff from Aristotle, Plato, from Einstein, from Planck and stuff like that. And I was like, we live in a world today where we are so enamored with information and content and stuff like that we don't have much time for really abstract thought. Do you know what I mean? Back then it seemed like they sat around and thought about the concept of time, of life, of everything. Now these days we're like, oh, we'll let the scientists tell us and we'll just watch it on Netflix in a documentary. We don't actually get to really send our minds on those thought exercises as much as you possibly got to back then, just because life is quick and fast.
And the structure of society as well, where there was, unfortunately, probably lots of slave classes and things like that did all their groundwork. And then there were lots of people that lived in the wealth classes that didn't do as much and had time to go to universities and think about these things.
Oh, we still have that now.
I wonder as well how much agriculture had to play in this ability to be able to have time to be able to
100%.
Explore these thought-provoking questions where you're able to, you're not sort of living hand to mouth. You're actually able to store food resources to...
You can be stationary and observe time a bit more.
You don't have to be following those seasons. You don't have to be chasing the migrations or anything like that. You just have everything right.
Interesting. Okay, so Corey, we are on to fact 2 for you.
Again, another kind of soft fact, I guess, but an interesting one. So depending on how cultures kind of structure different aspects of their kind of their understanding of like writing and writing direction and things like that, and interacts with their perception of time. So, for example, cultures that read left to right, right to left versus left to right, or vice versa, they actually perceive time to move in the same direction. And the Amerindians, I think, in South America, they actually see. So we are always moving forward into time, right, in our Western societies, whereas they see the future as behind them because it's the part that they can't see. So their past is in front of them because they have a clear vision of what the past was, but the future's behind them because they can't see, and it's always sneaking up on them.
Oh, that's interesting.
And there's another couple of other ones like how people perceive. I think the Spanish see time as full or empty. Like I have full time or I have empty time, as opposed to us seeing time as like long or short. And so their perception of time can be influenced by whether a glass is half full or half empty or is filling up at a different speed, whereas ours is based on how quickly something's moving in a linear fashion.
When the South Americans, sorry, I missed the name,
The Amerindians.
When is this an ancient civilization you're talking about?
Yeah, correct. So this is their traditional view of time movement.
Okay.
And I'd assume it would still be present. I can't speak on that for sure, but I'm assuming it's still present as an idea, as a concept, because it would be very well ingrained, just like it is for us. But yeah, I just found that interesting. That it makes perfect sense logically, right?
That you can't see behind you.
Yeah.
Remember what we did tomorrow.
Yeah.
I like it. Well, we'll just keep going around in the central circle today. So fact 3 for me is all animal species experience the same amount of time. So basically all complex organisms die eventually, but there exists a simple scale that relates to metabolism and mass. So bigger creatures live longer, but they have lower metabolism, so their heart beats slower, whereas small animals obviously have high metabolism and the heart beats faster. But when we break it down to a life, they cancel each other out, and every life form on Earth that has a heartbeat basically has a life expectancy of its 1.5 billion beats in a lifetime. Yet again, scary. Your days are numbered, which we know anyway, but also beautiful that we're all connected. The field mouse, the blue whale, the human, the monkey, the chihuahua.
So is this relative perception, as in like they perceive the same amount? So they perceive a lifetime as roughly the same?
Well, I can't speak on animal perception, but I suppose if you're measuring a heartbeat as a moment in time, as we possibly do as humans.
The same units.
Yeah. So basically, every living creature that has a heartbeat, their lifespan, not exactly, but the scale is set.
Correlation.
So the correlation between the two. So like, a giant tortoise will live for 150 years or 200 years. It's got a very slow heartbeat as opposed to the field mouse. It's like... Okay, Brie, fact 3, please.
Okay. The French tried to make it metric. So back in 1790s in revolutionary France, the government introduced the decimal system. So they were successful in bringing in the liter, the meter, and other 10 base metric numbers. It was a bid to change time to the metric system as well. So the day, instead of 24 hours as we know it, was broken into 10 hours. Each hour was split into 100 minutes, and each minute was made up of 100 seconds. That bid only lasted 16 months. You can imagine like the absolute chaos among society when, you know, the basis of our day and organisation is turned on its head. So then they went back to the normal 24-hour system. But if you're curious, 1 metric second is equivalent to 0.864 of our seconds. A metric minute is 1.44 of our minute. So it's the same as 1 metric minute is like us counting to 86, and 1 metric hour is 2.4 hours.
And what year was it? What century?
This was in the late 18th century, so 1790, French Revolution. So, you know, roughly 1 o'clock in the afternoon is only the 5th hour of the day.
I love that. That's a great fact because it's just one of those things where you see that
It's mind-bending.
that moment in time, if we had chosen to go that way, how different our perception of everything would be right now.
Yeah, I don't know of any other civilization. It was only the French that I read of trying to make time metric. Others may have, but yeah, it didn't go down well.
Okay, fact 3 for Nick.
Time has a preferred direction, which we refer to as the arrow of time. So events occur sort of in a linear time direction. So say if you crack an egg and cook it, you can't reverse that action, and in that case, the time is moving in that singular direction. But if you start to look at something on the atomic scale, or you're looking at a molecule that changes under different conditions, say under pressure or heat, that direction of time isn't so clear because the reaction can be changed. If those can
Fact off.
I love that you waited this far.
Yeah, I know. And the tone
I
of
was
the
like,
voice.
Make him squirm.
I was like, I don't have to explain it.
I believe, and it was quite tricky to wrap your head around as well, because we do think of time in a linear fashion, but really once you sort of scale down on something, that becomes irrelevant, because reactions, let's say a chemical reaction, can occur in either direction, and maybe you can explain this.
This is entropy, right? We're talking about entropy, right?
We are talking about entropy and the direction of time, the arrow of time. So basically, entropy at the start of the universe was low, and it's increasing. So things are becoming more disordered. The universe is spread out, more chaos. All molecules are starting to interact more and moving faster and faster and faster. Therefore, but looking at the fundamental laws of physics, gravitation, and energy and mass, those fundamental equations work forward in time and backwards in time, meaning that this may be possible. But the one that doesn't is heat. Heat always travels from hot to cold. Like when you cook the egg, you can't uncook the egg because heat doesn't transfer from cold to hot. Therefore, it's heat that they possibly think could be the driver of the direction of time. Okay. Because it's the only fundamental equation that breaks when you try to do it backwards.
There you go.
Oof.
Oof.
So fact off
then.
Well, listen, I am, because I did the questions, because Lauren has left, I'm going to choose a champion for this. And Corey, I'm going to get you to score.
Yeah.
You are going to fight for my honor.
You are going to be wearing the T-shirt.
I have faith in you.
Oh, God.
Are we ready? Fact 1. First answer wins, or closest to wins also. What is a decade?
10 years.
T-shirt's looking good. What is the shortest unit of time?
Planked time. Gotcha.
Ooh. How many time zones does Russia have?
It should have 11. No, that's China. But China works off 1. I think.
I'm sorry, I'm going to have to take your first answer. Nick?
1.
11.
Ah,
Did I cheat there? Was that cheating?
No. That's valid. That's valid.
Yeah. No, it's a very wide country.
that's impressive, Bree. That's
I read
impressive.
that last night.
Yeah. No, that's blown my mind.
Okay. In what century was the mechanical clock invented?
The 19th century.
18th century.
The 14th century.
Oh, closest wins.
Closest wins.
Oh, really?
Okay. And number 5. This is going to be interesting. What is a light year?
The length of time it takes light to travel.
You
I
Keep
don't
going.
know what unit of distance. Just
I would have accepted buzz, but
sorry, it's the distance that light can travel in a year, isn't it?
no, look, you're right. It's a unit of distance, not time.
Sorry.
It's the distance the light can travel.
Yes,
within
the
that
year is actually the distance.
Well played.
Maybe 10 pictures off you, Nick. We will see. That's a good fact. I enjoyed that. I
Yeah.
enjoyed the reading about entropy. That was interesting. We are on to fact 3 from Corey.
Everyone's heard of a quartz clock? Yes.
Yes.
Watches, clocks. So the way that quartz measures time is by interacting with the Earth's magnetic field. So the Earth's magnetic field operates in a pattern that interacts with the light material of the quartz, and it's that pattern that's tracked within it that gives off basically a consistent cadence, I will say. And because of the seasonality and the change in the magnetic field, the quartz clocks actually drift, but they're still much more accurate than traditional grandfather clocks and things like that, which rely on gravity to measure time.
So it's a vibration it's measuring, basically.
Yeah, correct. Yeah. Although, it's the movement of the magnetic field, like through space and time or whatever you want to call it. Yeah.
And does it measure it in force, like quartzily?
Quartz being
That
the
was
material.
terrible.
No, but it's in the thousands. It's measuring thousands of units of movement in the quartz to gauge a second or whatever it is. I can't remember exactly what the number is, but I'm more than happy for someone in the comments to put what that number is.
Okay, fact 4. Okay, there's no such thing as a universal now. Because the speed of light, as we were just talking about, is finite, then there is no universal now, because if we observe something, we say that is now. I'm observing Bree looking at me now, which is fine. There is a slight millisecond of the light hitting her, hitting me, but we can kind of conceive that as now. But if something happened somewhere else in the universe, now we would not know about it until that light got to meet us. So there is no universal now. So if we were to travel to Mars, Earth will be anything that happened now on Earth would be 3 to 24 minutes in the past, depending on the orbit of Mars. If we were to travel to our closest star, which we visited in episode 1,
yes.
which is Proxima Centauri, everything that happened now on Earth would be 4.25 years in the past. Therefore, now does not exist on a universal scale.
That's crazy.
I question that fact.
Oh, you question, and the opposite is also true. So if we were to travel to Earth at the speed of light, or just at the speed of light, then we'd see advanced light. So the light we'd see from Earth would be stuff that's happening in the future.
But it's based on perception, right? So there's no universal now for any one person, but there's a universal now at any given time across the entire universe if it's not perceived by any one individual.
Yeah, and again, if we're relating to block time, then you could take a slice of this and say that's now a universal now, but still for everybody to observe that, it still wouldn't be now. It would always be in the past, or in the future.
So an individual would have to, for that individual now, I would have to be in two places at once in order to perceive that universal now at the same time. Yeah.
But essentially, it wouldn't matter where you are within the block if you're here and experiencing time from. If you're at one point in the block and you were perceiving the light from stars or whatever planets, you're receiving that information is different to when the time.
Yeah, that's right.
The local time.
That's right. Yeah.
Or to put it more succinctly, it's all relative.
It's all relative. Time is relative.
Okay, so we'll move on to Bree's fact 4.
Okay, so the Earth's core is younger than the crust.
Yeah.
Crazy. And you think, how can you form an empty crust and then fill in the core? So Richard Feynman was an American physical theorist, and in the 1960s he predicted or worked out in his head that the core, that there was an age gap of about 1 to 2 days between the crust of the Earth and the core being younger. It was still assumed that the core was formed prior to the crust, but given general relativity and that time is affected by gravity and that there's greater gravitational force at the core of the Earth, that has slowed down. So the core has aged slower than the crust.
I like that.
Fact 4, Nick.
According to the theory of relativity, as an object reaches the speed of light, time starts to slow down. And in theory, to an observer, an object traveling at the speed of light would essentially, for that object, time would stand still. However, no object with mass can actually travel at the speed of light, so
Fact off.
time will never actually stand still.
Yeah, well, I mean, mine was basically a really small subsection of that. So as something, a unit or an object approaches the speed of light, time stands still, basically. So yeah, without all the additional detail, but I think that's probably close enough because that was the fact, right?
Yeah, so in theory, if an object with mass could travel at the speed of light, time would come to a halt.
I think we need to put some Hans Zimmer soundtrack in here.
I'm just thinking it's like the ultimate day spa, the ultimate fountain of youth.
Oh, my God.
Light speed spas.
Yeah.
Stop time.
Remove your crow's feet.
But would you still age?
This is what I query.
Yes, you would, but not.
Not at the same
Cells
speed.
still break down.
Time would stand still to the observer, not the mass experiencing the speed of light.
That's the point. You've got to have 2 points of reference. If you've only got 1 point of reference, then theoretically you would age. You would age.
You would experience age or time just as
it is, but in relative to another observer, then you would appear to be younger.
Yeah.
Okay, so we have a fact off.
Okay, question 1. What is a millennium?
1,000 years.
Correct. Who first proposed the concept of time travel?
That's a good question.
Einstein?
I have no idea.
H.G. Wells in 1895
nice.
in his
Yeah,
novel
of course
The
it
Time
would have
Machine.
been. Yeah, of course.
Yeah, science is normally preceded by science fiction.
Yeah.
What is space-time?
They are dimensions. There's 4 dimensions or 3 plus 1. 3 of them are spatial. 1 of them is time, and it's their interaction between the 4 or the 3 plus 1. I don't know.
Space-time is essentially the 4th dimension, I think.
I think you've both hit it, but Corey got in first. Space-time is a concept in physics where space and time are fused into a 4-dimension continuum. Okay, why do we have leap years?
Because there are...
It's a fraction. There's a fraction more. I don't know what the fraction is, but there's a fraction more of a day every year that we need to account for. And if we didn't put it in there every 4th year or whatever it is, that we would be behind.
Okay, now I'm going to say the person that's going to get the point is the person that gives me the fraction because it's super simple.
A quarter.
Yeah, so we have leap years to keep our calendar
Fair
years
enough.
synchronized with the solar year. because a year is
I should've-
approximately
yeah.
365.25 days long.
Yeah, that was an easy. That was a.
I would have accepted a quartzer also. Just letting you know.
Okay, question 5. What are the 7 most common units of time?
Seconds, minutes, hours, months, years, centuries, decades.
Milliseconds, microseconds, seconds, minutes, hours, days, years.
Oh, God, they've
Have
both semi-covered it. So it's your call. It's seconds, minutes, hours, days, weeks, months and
Weeks.
No, it doesn't matter if we give them both a point.
years. Yeah.
I don't think.
I'm still wearing the shirt.
Yeah, I'm happy that I don't have to buy another shirt this episode. So that's good. So we are on Corey's fact 4.
All right. So I guess circling all the way back to something Bree was talking about, and we had this big discussion about our perception of time and how we've kind of increased our ability to measure it in finer and finer increments. So in 2019, the definition of a second was updated based on our access to atomic time or atomic clocks. So yeah, now we measure time or we measure a second. 9,101,631,770 hertz. So vibrations from microwaves moving through the atom and changing the position of electrons in that atom of cesium.
It hurt listening to you read out that.
Yeah, it's a big number. But anyway, yeah. So now the definition of time is based on the movement of, or the vibration of a microwave moving through an atom and moving the electrons up and down in that atom. Yeah, so that's the official definition of a second. I found that interesting because that's quite precise.
That was updated in 2019.
Yeah.
Okay. So we are on to fact 5 for Bree.
Okay. So the railway was one reason that Britain standardised time. So in the mid-1800s, towns and villages across Britain were still using local solar time. So their day was based on when the sun passed over them. All well and good for them, but you take it out to a national scale, you know, everyone's working off a different time. So Greenwich Mean Time did exist, but so did Bristol Mean Time, which was 10 minutes behind GMT, and so did Cardiff Mean Time, which was 13 minutes behind GMT. There was also no national convention on how to measure time. So there was no standard on when the day started, when the day ended, or even how long 1 hour was. So you can imagine 1850s, 1860s railway network expansions, main means of transport. Thousands of people were missing their trains because each railway network had thousands of timetables for each line because every town had a different time system. So it was chaos, absolute chaos. And so the country couldn't function. So mid-1800s, the various different railway companies introduced a national time. They decided to base it off Greenwich Mean Time. So that became adopted to try and simplify timetables, which was good. Then after that, all the public clocks started getting set to Greenwich Mean Time, which at that point had been given the adopted name of railway time. And then in 1880, it became the national standard time for Britain.
I would just like to say, growing up in the 80s in the UK, they didn't standardise time because trains never ran on time. They got their equations wrong. But yeah, that's it's an interesting fact that yet again, the necessity of civilization enacted that us to adopt more universal values that that eventually spread around the world.
Yeah. And as I guess, I mean, we need to adopt that because we need to interact with people. We need to be able to have a common discussion about time and things like that. And if we're not sharing the same concept of time, then it's really hard to communicate, I guess.
Need to be functional as a society.
Yeah, that's right.
Okay, Nick, fact 5.
This ties back into relativity of time somewhat. So if you think about the amount of time that you have been alive for and how you perceive the relevance of time, it changes throughout your life, throughout particular events. So say for a child that's lived for 2 days, a newborn, 1 day is 50% of their life. But as you get older, a day relative to your entire lifetime
Tis but a blip.
becomes less and less relevant. So indeed, that's why as we get older, we feel like time speeds up. And, here we are sitting in, middle of the year, it's end of the financial year. We've got Christmas around the corner. It just feels like yesterday we had Christmas of last year. So that relativity of time changes throughout your life. And so certain events that can, change this perception of time are things like a car accident where it feels like time is slowing down. There's certain moments and events that can really shift and alter your perception of time.
That's why I decided to only have Merry Shipmas once every 2 years to elongate our perceptions of time, to slow down us all growing up. And if you've ever been to a Merry Shipmas party, that's basically what happens. We regress to our childhood.
No, I was just going to say, we've reached that beautiful point in life nearing middle age where we get to enjoy those conversations every time we bump into someone. Can you believe it's the 1st of July already? Where's the time gone?
It's that and weather.
I remember where you could buy a tank of petrol for a chicken.
When I was your age.
Right. Okay. Well, we are at the end of the facts, I believe. First of all, we have to find the lie. Now, because Brie and I did have conflicting views, one of us is telling the truth and one of us is lying. So we will go through all of our facts now, and you guys get to choose which fact you think was a lie from both Brie and I. So Brie, if you give us a rundown of your 5 facts, please.
Okay, my recap. The days are getting longer, which is where we differ. The Egyptians and the Babylonians did it first. The French tried to make it metric. The Earth's core is younger than its crust, and the railway was one reason the British had standardised time.
Okay, and mine is block theory is supported by the theory of relativity. Days are getting shorter. All animal species experienced time the same because of the heartbeat. There's no such thing as a universal now. And heat could be the main cause of the arrow of the direction of time because it increases entropy.
Well, I mean, the first one's probably the challenging one, right? So because you're in conflict, so someone has to be wrong.
Someone has to be right.
Yeah, exactly. And I think years are potentially getting longer, but days are getting shorter. So on the day fact, I think I'm gonna say Kieran's right.
Yeah, I think I'd have to agree there.
I think I'm right because everything I read pointed to my fact.
Brie is right. That's a big fat lie. It is actually reversed. So the length of the day has been increasing due to what Brie said. So, yep, it's still, all the science is the same. The maths is the same, 1.7 milliseconds per century. That means in a million years' time, a day will be 25 hours, not 23 hours. And in a billion years' time, a day will be 30 hours long, not 18 hours long. Therefore, a year will be 372 days. So, yes, Brie was telling the truth. I was telling a lie. I tricked you.
Yeah, well done.
You were convincing though.
Okay, so now right. I get to try to pick out Brie's lie. This is a tough one because I haven't read anything about the core, and some of the stuff I've read does make sense in what you're saying, but also it was my understanding that the timetables were first tried to be standardized by the Americans. That's where it was first trialed. And we couldn't actually agree on a universal time. Then we ended up agreeing to breaking it down into time zones, and everything came from Greenwich Mean Time. But I think it was the Americans that standardized railroad timetables first. So I'm saying that that's the lie.
Okay.
I'm going to have to agree, I think, from what I understand. I'm pretty sure the Americans, when they were building the railway across from east to west, I thought. But anyway, yep.
I'll go with the Earth's crust being older than the core.
Okay. So you two are wrong. Yeah. Mr. Royal is correct. So I'm going to have to read
My justification for this, I was thinking about it. So you have the Earth's core, you have your tectonic shift on the surface or on the Earth's crust. These tectonic plates will have points of collision where, essentially the Earth's crust will
Fall into the core.
and become recycled. So really, from day dot, anything that's been on Earth has been, I don't know, recycled.
So it was that the Earth's core is younger than its crust. That's the lie, but not in the way that you might think. So I'm going to read this out. Danish physicist, and I apologise to any Great Danes listening, Ulrich Ugerhog, I don't know how to
Nailed
pronounce it. So he cited Richard Feynman's famous work, and it had been used everywhere. But what he realised is that no one had actually tested his theory to confirm the numbers. So what he and his team found was that the time at the core had been lagging behind the time at the surface for a mere fraction of a second. And you can put this one on the screen. So the time at the core was lagging around 0.000000003 of a second, which seems negligible. But over the course of the Earth's 4.5 billion year lifespan, this added up to a 1.5 year age gap. When the difference of density of the core and the surface were also factored in, that age gap was adjusted to 2.5 years. So it wasn't 1 to 2 days. So they're not sure whether Feynman was just misquoted or he just fumbled saying days instead of years, but they estimate 2.5 years difference in age between the core and the crust, the core being younger. Now, obviously, this can't be proven conclusively. No one's digging down to do little
one's
DNA
going down
samples.
Yeah, so the core is younger, but just not by that time.
Correct.
Okay.
However, this was calculated using general relativity, and general relativity has passed every single test thrown at it so far. So this is likely to be correct.
Okay, so let's do Nick's recap.
My first fact was about Louis Essen, the inventor of the atomic clock. Spoke about the arrow of time, time's relation to the speed of light and time slowing down. The base 60 system and the invention of the sexagesimal, love that word, time not being universally experienced.
Okay, now, because we kind of co-opted on our arrow of time, I assume that's got to be true, but yet again, it was such a big subject that half the stuff you said could have been lies, and I would have been like, yeah, it sounds like what I read, so yeah, that's fine. But I'm assuming that that's true. I'm going to have to go with atomic clock only because I didn't research much on the atomic clock, and that's the only one that's not ringing any alarm bells. There's so many time puns in this. So I'm going to go atomic clock, even though I really have no idea because I know fact all about it.
I'm going to have to go the Sumeria one only because I did do a bit of reading. I mean, that the only thing that could potentially be out is the names or something like that of the people in the atomic clock stuff because I wasn't paying attention to that. But purely based on the fact that speed of light, atomic clocks, all of that sound right, bar like maybe a couple of little facts that I overlooked, I'd have to go, ancient civilizations.
Mm-hmm.
I'm conflicted on the same two facts. I know nothing about the atomic clock, and there was something in there that sounds fishy. But with the Sumerians, I thought the sexagesimal, is that right? Sexagesimal system was adopted much later, calculating 360 degrees on the planet, divided by 15 degrees, gives you the 24. I thought that 24-hour system came later. So I'm going to say that.
So I threw a bit of a curveball on the inventor of the atomic clock.
I knew it.
So there was no single person that came up with the invention of the atomic clock. It's over time, it's been a collaboration between a number of different researchers and scientists. So essentially, the invention of the atomic clock cannot be attributed to a single person. There's been a collective effort from scientists like Louis Essen, Norman Ramsey, and many others who have been essential in the establishment of the knowledge we have behind the atomic clock and the technology that's been developed to be able to measure time with such precise accuracy.
Oh, hang on. The sound of victory. Sorry, carry on. Okay, and Corey, let's have your recap, please.
All right, recap. So we had Cleopatra and Pizza Hut. She's going to go there and get some Pepsi. We had cultures and time, so their perception of time, and their. We had the quartz clock responding to the Earth's magnetic field, and we had the official definition of a second being updated in 2019.
I will go with, oh God, civilization's perception of time.
Okay.
Okay, Nick?
I'd have to go with the update to the measurement of a second.
Okay.
I'm going to go with the second update because I think in the connected world that we live in, if it happened in 2019, we might have heard something about it. But then again, we were dealing with other problems in 2019, so maybe it just slipped under the radar as we're all wearing masks.
So you're all wrong. So the made-up fact was the quartz clock. So quartz is actually, it vibrates. If you put an electric charge into a little piece of quartz, it vibrates at a rate. And that's what tells the time in a quartz clock, is the vibration based on electric charge.
Not the magnetic field.
Nothing to do with magnetic fields, nothing to do with seasonality changes. It's just that that's a little battery pumping in a charge to a quartz crystal that vibrates, and it measures the vibration. Yeah.
Very good.
Beautiful. Okay, well, all that's left to say is thank you to Bree, to Nick, and special guest star Corey. This has been an interesting one. We are all now going to choose what the next episode should be about. We have a new guest star. Next time it's Sophie. And I'm giving the guest stars the ability to channel through me their choice. So I'll reveal Sophie's choice last. So Corey, what would you like for us to research and talk about next on I Know Fact All About That?
I think quantum physics would be a good one to throw in there.
So
I'm out.
if you would like quantum physics, type in the comments below, I want quantum.
Sharks.
I'll be quiet at home with that one. If you would like sharks, type in the comments sharks or dirtum.
Fungi.
Oh, that would be
that's a good one.
Yeah.
If you want fungi, just type in the comments down below, fungi. And Sophie's choice is sex.
Oh.
Of course it is.
So if you'd like Sophie's choice, type down in the comments, I want sex.
Is this going to be R-rated?
Oh, keep an eye out on the channel. There's plenty more I Know Fact All About That coming up. How Not to Make a Movie, our new show, will be debuting next week as well. There'll be another episode of the Sarah Shark documentary and another 2 or 3 PSVR2 videos on Virtually Real. So please like, subscribe, stay tuned, and we'll see you next time.